Okay, here we go. 2.4, we're looking at word problems. So word problems are definitely one of the things that can cause students a lot of stress. So I have a way of approaching them where we're just kind of come in here and start looking at this English sentence and kind of do a part of the way translation into a mathematics statement and then bring it all the way into that mathematics statement. So this is called kind of blueprinting, and it's kind of like if you ever took, if you ever in an English class did sentence blocking where you're looking at the subject and the predicate, stuff like that. It's sort of like that. If you never did that, no worries. So I'm just going to go through here. Twice a number. So twice a number, that usually is going to mean 2 times something. So I can say 2 times a number. I'm just going to write that like this. A number added to 7. So now that thing, 2 times a number, is going to get added to 7. So this thing will be added to 7. Technically, the 7 will be over here. 7 plus that. And now, as I'm going through this sentence, is always going to be a keyword for me. That is usually is going to mean an equal sign. So this is the same as, this is a big indicator to me that there's going to be an equal sign here. So I can put that there. 3 subtracted from. So 3 is the next thing I'm looking at here. I'm trying to pick a new color. Here we go. 3. And now that 3, what's happening with that 3? I'm going to keep reading. It is being subtracted from something. So there's going to be something going on here. And then 3 is going to be subtracted from it. And now what is 3 being subtracted from? 3 is being subtracted from the number. Okay, so now this thing here is kind of my blueprint where it's not fully algebraic, and this is going to be maybe a little more productive when we have more applied problems, because this is really just a translation of a mathematical statement to an English statement. What I'm going to do next is make a let statement. So let, because I don't want to keep writing a number over and over, let x is going to be the variable I introduce, be the number. And now that let statement is what's going to let me go from this blueprint idea to a pure algebra statement. So I'm going to say 7 plus 2 times a number. That's going to be 2 times, now I'm letting a number be x, so I'm going to write x instead of 2, and that is equal to a number minus 3. And now I have just a nice purely algebraic statement, and I can go through and solve this like we've been doing so far in chapter 2. So for example here, I want to get all my variables on one side first. I have a variable term over here and over here. These are my variable terms. I'm going to subtract x over here, and if I subtract it from one side, I have to subtract it from the next side as well. So then I get 7 plus x, just 1x, equals negative 3. And then I'm going to subtract 7 from both sides. And I end up with x equals negative 10. And then usually when you're doing word problems, it's a good idea to have your final answer be a sentence. They will usually tell you what they're looking for. Find the number. So that's the thing they want. So I can say the number is negative 10. Okay, next problem here. This is just a little bit more complicated. Twice the sum of a number and 4 is the same as 4 times the number decreased by 12. And now I know this kind of sentence is not a lot of fun to read. You can kind of panic. You can always look at this though. So to kind of calm yourself down, here's is, that's going to be my equals sign. So I'm going to have an equation here. And this is, if word problems are something that you struggle with, don't try to figure out the answer right away. So I usually tell students, instead of trying to get 5 points right away, just try to get 1 point, and then try to get one more point and just keep kind of building up, because those little steps are going to help you get to the end. So twice, I know about twice. Twice is 2 times something. So I can kind of remind myself that that's what that means. Now, what is getting doubled? The thing that's getting doubled is the sum of a number and 4. So it's 2 times the sum of a number and 4. Sum means addition. So in here I've got the sum of 2 things, a number and 4. So I have a number and 4. This is the sum of a number and 4. And now that whole thing is getting doubled. So right now, because of my order of operations, if I leave it like this, only the number would be getting doubled. So I want to put some parentheses in there to get, now the sum of a number and 4 is being doubled. And that is the same as 4 times the number. So 4 times, so times means multiplication is happening. The things that are multiplying here are 4 and the number. So I have 4 times a number decreased by 12. So decreased by, that means subtraction, minus 12. Okay, so now I can make my let statement. Let x be the number. So then I end up with this nice statement, 2 parentheses, x plus 4 is equal to 4x minus 12. And now if you made this let statement, especially in a problem like this, you know what you're going to be looking for. They say find a number. So you can make your let statement and go straight to this. This blueprint idea is one of the things that's here to support you when you need it. So now I'm just going to go through, solve this equation. I'm going to start by simplifying both sides. I'm going to simplify the left. That 2 is going to distribute. So I have 2x plus 2 times 4. That equals 4x minus 12. So then I end up with 2x plus 8 equals 4x minus 12. Now I have variables on both sides. I want to get those on only one side, so I'm going to subtract 2x from both sides. And that gives me, coming up here, 8 equals 2x minus 12. I'll add 12 to both sides. And I get 20 equals 2x. Now x is almost alone. It's connected to 2 by multiplication. I'm going to undo that multiplication with division. And I end up with 10 equals x. So I really should say the number is 10. Okay. So here's another one. And this is an example. Now we have like a real, this is like a kind of a real word problem. Balsa wood sticks are commonly used for building models. A 48-inch balsa wood stick is to be cut into 2 pieces so that the longer piece is 3 times the shorter piece. Find the length of each piece. So when you're looking at a word problem like this, there's kind of a lot going on here. First of all, this is totally cool. It's true. Balsa wood sticks are commonly used for building models, but that is not relevant to me in doing this word problem. So I can just not worry about that, you know? And that can be, sometimes people can get really stuck on stuff like that, especially sometimes in a problem, if they say something about a year or something like that, there'll be a number there, and then people will try to put that number into the problem. So be aware of what's really part of the problem. So now going through here, a 48-inch balsa wood stick is to be cut into 2 pieces. And if you don't see how to set this up right away, this is where this blueprint idea can really help. So there's 2 pieces. We have a short piece and a long piece. So I'm just going to kind of draw a really simple picture here of what's going on. Here is a balsa wood stick. It's getting cut into 2 pieces. And then we're going to have a long piece and a short piece. So I'm going to make my little blueprint idea here. The long piece plus the short piece and there's any kind of word problem, and this comes up a lot. One thing that's true about this balsa wood stick here is this whole thing is 48 inches. And so that means my long piece and my short piece, they have to add up to the total length of the stick. So the sum of these 2 pieces is 48. So that is one thing that I'm doing just to kind of organize myself. And I haven't worried about the rest of this yet, and I don't have to right away. Because now I've got this, and when I'm talking about building up just a couple points at a time, this is looking pretty good. I drew a picture, that's probably going to be worth a point. Then I've correctly interpreted this idea about this being 2 different pieces. I haven't solved the problem, and maybe I never figure out how to get that part, but I've got something rolling. And once you've got some progress, then it's a little less stressful to move on to the next thing. Now, the longer piece is 3 times the shorter piece. So in this sentence, there's some kind of, going to have some multiplication happening. So I've got some multiplication happening here. You always want to have your eye out for that word is. So here I've got this is, the long piece is 3 times the shorter piece. So this is giving me another equation here. I can say the long piece is 3 times the shorter piece. Okay. Now, what I can do, so now I've got my blueprint set up. I'm pretty close to being able to solve this, but it isn't quite in a nice mathematical format. So I want to convert this, and I'm going to make a let statement now for my variable. It can be a little confusing here where I have to find 2 things, and I just want to let one of them be a variable first. And so usually I think a good choice is the thing that has the most happening to it. So here the short piece is getting multiplied by 3. So I'm going to let x be the short piece. So let x be the length of the short piece. So now the second equation, and this is important, my long piece is 3 times the short piece, which now is x. And so that means I can take this. Equals is a really, really strong relationship. That means if these are equal, 3x is the same as the long piece. So I can take that and substitute If the long piece is exactly 3x, that means the long piece is exactly 3x up there. So I can take that first equation, this guy now, I'm going to bring this down here. I've got the long piece is 3x, so 3x plus the short piece is just x, and that is equal to 48. And now I have it down to just a nice mathematical equation. So from here on out, I don't have to worry about balsa wood and cutting things and any of that word problem stuff. I can just go through, combine like terms, and then completely isolate x. X is being multiplied by 4. I'm going to undo that multiplication with division, and I end up with x equals 12. So now, x equals 12, and this is where having that answer sentence is even more important than it has been in the past. So they wanted the length of each of these pieces. I found x, that's only one of the pieces. And in a complicated word problem, it actually can be hard to keep track. Sometimes you get to your answer and you're like, crap, I don't even remember what this is supposed to be. But x, I have my nice let statement here. My let statement tells me what to do with that. Like if I'm like, hey, what is x? I forgot. I've done all this math. X is the length of the short piece. So I can say the short piece is 12 inches. And then the long piece, I know from this equation that the long piece is 3 times whatever the length of the short piece is. The length of that short piece is 12. So 3 times 12, so that is equal to 36. The long piece is 36 inches. And this then is my complete answer. Okay, that's it for page 1. Let's move on to page 2 here. Okay, here we go. The 112th Congress began on January 3rd, 2011, and had a total of 435 Democrats and Republican representatives. Okay, so that is a little confusing to read. The total number of representatives here, there's some Democrats and some Republicans. The total number of both of them together is 435. There were 49 fewer Democratic representatives than Republican. Find the number of representatives from each party. So, this is a really good example. All I care about is finding the number of representatives. So in this case, and this is cool, this is true, history, whatever, but I don't need to figure out which Congress this was. I don't need to figure out what time it began. So all of this information is not relevant to my problem. And this is an example, like I talked about a little bit in that last problem. You can get into some trouble. Sometimes people look at a problem like this and just say like, okay, well, I don't know, 112 plus 2011 equals 435. And, that's not going to help. So what I'm looking for here is a total. And I know that the Democrats and the Republicans together, I know how many there are. So I know that the Democrats, and I'm just going to create this little blueprint idea. The Democrats plus the Republicans equals 435. And I got that from this word total. Now they're also giving me a little bit of information about how those quantities are related. There were 49 fewer Democratic representatives than Republican. And so this is worded in a way that I think is a little more confusing because we don't have that nice is to orient ourselves. But there are 49 fewer Democrats. That means there's a smaller number of Democrats than Republicans. So the Democrats have some relationship to the Republicans here. And so now what's happening, if there's a smaller number of Democrats, that means I'm going to have to subtract from the Republicans. So there are 49 fewer Democrats than Republicans. Find the number of representatives in each party. So now we're going to do the same thing. I'm going to, and this is pretty similar to the last problem. It looks really different, but once I have it here, I've got these two different equations. And I'm going to make a let statement to introduce a variable. Again, I'm going to have that be the thing that has the most happening to it. So Republicans are having 49 subtracted from it. So I'm going to let x be the number of Republicans so that means Democrats, this equation becomes this. Democrats equal x minus 49. And that is going to let me take my original, this first equation, which was Democrats plus Republicans equals 435. And now I know Democrats is exactly the same as x minus 49, so I can say x minus 49 plus the number of Republicans, there are x, that equals 435. And so now the idea with this blueprint is it gives me some structure to once I start getting this other information, I'm just plugging it into this original statement that I made. So this equation here is the same as this equation here. And now all I have to do is a little bit of algebra. I have positive x here, positive x there. So when I combine those, I have positive 2x. That minus 49 stays there. That equals 435. Now I want to isolate my variable term. I'm going to add 49 to both sides. And I end up with 2x equals 484. And now to get that x completely isolated, I'm going to divide by 2. And I get x equals 242. Okay, and now what is x? I have this let statement. So I can say there are 242 Republicans and let's see. So the Democrats are equal to x minus 49. So the Democrats are x, which is 242, minus 49, and that gives me 193. And now the nice thing about a word problem, and I know they're not everybody's favorite, but what's cool is once I'm here, I can check to see if this makes sense. There were 49 fewer Democrats than Republicans. Does this, okay, yeah, there's fewer Democrats, there's more Republicans. That adds up to what they're telling me. Do these two numbers add to 435? They do. So you can be pretty confident once you get an answer to a problem like this. So this next one here is a group problem. I'm going to give you a little bit of a start here. There is one thing that is true about a triangle, and this is something you should know, is the angles in a triangle are always going to sum up to 180. So if I'm looking at this triangle, I have the first angle. So that first angle plus the second angle plus the third angle equals 180. And that's true of any triangle that you can draw. Any triangle that exists on a two-dimensional surface is going to have this property. The sum of all three angles is 180. So this is the blueprint that you're going to use. So then you're going to go through and take all this information, figure out how to put things in terms of some variables and how these things are related, and see if you can figure out those three angle sums. And I again will put those solutions on D2L. Okay, that's it for part 1, and we have part 2 coming shortly.